Hello everyone, let's start with the problem count pair sum in matrix. So this problem is from Geek for Geeks, and it says given two matrices mat1 and mat2 of size and cross size. Basically this mat1 and mat2 is of 2D matrix and whose size is n cross n, where the element in each matrix are arranged in strictly increasing order. So yeah, elements are arranged in strictly increasing order. Specifically, each row is sorted from left to right. So each row is sorted from left to right in ascending order, strictly ascending order. And here strictly ascending order meaning we don't have any repeated elements. Yeah, and the last element of the row is smaller than the first element of the next row. Okay, so we have, let's say, current row, and its last element is smaller than the next row's first element. So basically it is sorted from left to right, and then in next row the first element will be bigger than the last row's previous row's last element. So in this way it is sorted. I'll tell you what it is in basically. You are given a target value x. Your task is to find and count all pairs a comma b such that a is from mat1 and b is from mat2, where the sum a plus b equals to x. Okay, yeah, so let's try to understand the example. So it is saying they have given first case wherein we have mat1 and mat2, and if you see they have given as elements are increasing order from left to right. So as you can see they are increasing. 1 is less than 5, 5 less than 6, and in the next row they are saying like the last element of the present will be smaller than the first element of the next row. So as you can see 6 is less than 8, so it is sorted this way. In this way it is sorted. So how do we solve this problem? If you try to solve using brute force, so in that case what we'll do is we'll take first element of this and compare with all the elements of this matrix. So in that case we'll have to find, so they have given a should be from mat1 and b should be from mat2, and that has to be equals to x, which is target basically. So if you see if you choose this element from first element from mat1 and rest all the elements will be compare. So 1 plus 2, which is basically 3, is not equals to x is in this case given as 21. Okay, x is equals to target is basically 21, so it is not equal. So in the same we'll compare 1 with 4, which is 5, is not equal to 21. 1 with 7, which is 8, will not equal to 21. So at the end when you come 1 and 20, so 1 plus 20 will be equals to 21. So you have found one pair. So you will have to increase count plus plus. Okay, so I think you're getting what you're doing. We are taking first element, comparing with mat2 of all the elements, taking second element, comparing all. So in this case as you can see there will be one for loop, two for loops for picking one by one element from mat1. One by one element will be picking from mat1. That can be done in two for loops, and once you are picking one element, so you'll be comparing with the other for loop, other matrix. That will again take two for loop, which will be running from 0 to n minus 1. So as you can see time complexity will be order of n power 4, and in the example if you see n value is 100. Okay, so 100 means n power 4. So 100 is basically 10 power 2 into 10 power 2 power 4. If you do that is basically 10 power 8, and 10 power 8 means it will be exceeding the time complexity of 1 second. So this will be a brute force solution. So we need to somehow optimize this. So how can we optimize? Let's try to understand. Okay, so if you see this is simple math, like a plus b equals to x. So can we write this way, like a is equals to x minus b? Can we write this way? This is correct, this simple math. So what we are trying to do is, okay, so we will be inserting all these elements from matrix 1 into a unordered set. Okay, unordered set we will be inserting into unordered set. Let's say we will insert all the elements 1, 5, 6, 8, 10, 11, 15, 16 and 18. We have inserted every element. Now we'll be going into all these elements, basically two for loops. Okay, one by one we'll be picking element from this. Let's say first one we have picked as 2. So our a will be a is equals to x is basically 21 minus first element is 2, so a is equal to basically 19. So we'll try to find if this 19 is present in this set. As you can see, it is not present, so we'll discard the first element. We'll go to second element. Let's say we have went to second element and it is 4, and this is basically 21 minus 4 is 17. We'll try to find if 17 is present. We don't have 17, so we'll go to third element. Let's say 7. Okay, we went to 7, so this is 21 minus 7 is 14. As you can see here, we don't have any 7. So basically we'll go to through all these elements one by one, and we'll do x minus that element, and the remaining element, that is basically a, if we'll try to find if that is present in this matrix. But we were initially doing by using two for loops, but we have reduced the two for loops using unordered set. So in this case we'll find if it is found, so we'll increase the count. If it is not found, then we don't decrease the count. So I think pretty much you got problem statement how we are doing it. So in this case our time complexity will be reduced to n square multiplied with 1. I'm using unordered, so its time complexity is 1 only. So in worst case it will be n square, but let's take it as 1. Or else if we use ordered set, that will be n log n. Okay, n log n, basically n square log n. Yeah, log n it will be, sorry, not n square log n, it will be log of n square. So in this case we'll be taking unordered set only, and space complexity will be O of n square, because all the elements of 1 we are storing in unordered set. So yeah, it's time to solve the problem. Let's try to code it up. So yeah, first what we'll do is we'll take one unordered set of int. Let's name it as st. We'll take n, basically mat1 dot size. They've given both are intros and size only, and yeah, and we have found it. We'll go to one by one all the elements of first matrix in this way. I think you know how to go in there, and we'll insert into vector, this set mat1 of I and j. We have inserted all the elements into our unordered set. Now let's take int count equals to 0, which is basically counting the pairs. Now we'll add it through second matrix. J less than n, j plus plus. We are iterating through that, and let's say take int b is equal to mat2 of I. We have found this thing b, which is basically the element of the matrix 2. We'll take a is equals to x, which is target here. In this case, as you can see, this is target. Since a plus b is equal to target, so we are finding a, and that a we will be finding in this matrix present or not using the unordered set. So what we'll do is we'll try to find if st dot find of a not equals to st dot end, which means in this set we have that element. Basically a is present in this matrix, so in that case we'll increase count by 1. Else if it is not present, we don't do anything. We'll move to the next element, and at the end we need to return count. Let's try to run the code. Here it got accepted. Now let's try to submit the code. Here it got submitted as well. So in this way you can solve the problem, and yeah, it is a very easy problem, not that hard. So thank you guys for watching my video.